starting a new topic today, force as vector quantity and it's also known as resultant force in some texts. Resultant force. Let's discuss a little bit of theory behind this before starting the worksheet. Okay. So the concept of resultant force is, let's say there are a few forces acting on a point. There's a force in this direction. Let's say there's a force in this direction. There's a force in this direction. There is going to be a resultant force from all these forces combined. Now that resultant force is represented by R. Let's say the R is going to be in this direction, for example. We'll talk more about this direction later. So because of these three forces, there's a resultant force, that is a net force acting as on the same point as a result of these three forces acting on different directions, acting in different directions with different magnitude. Okay. So the resultant force always has an X component, we call it Rx, and the resultant force has a Y component, we call that Ry. Now, how do you find Rx from the question? How do you find Ry from the question? I mean, from the given forces, from the given three forces. Okay, Rx is equals to forward forces in X direction minus backward forces in X direction. And Ry equals forward force in Y direction minus backward force in Y direction. If you have Rx and you have Ry, you should be able to find R using Pythagoras theorem. If you have Rx and Ry, you should be able to find the theta of R, the resultant force, which is theta equals tan inverse Ry over Rx. If you have the R, the resultant force, then you may use this formula. R, or the magnitude of R, equals to MA. Again, if you have the resultant force, you can use the formula resultant force is equals to MA, or the magnitude of resultant force is equals to MA. You don't have to use forward force minus backward force is equals to MA. You can instead just use resultant force is equals to MA. Similarly, if on a point, there's let's say movement is in this direction and there's friction in this direction. And instead of all the forward forces, you know the resultant force. So you can use the formula R, or the magnitude of R. R is actually a vector. It has a magnitude and it has a direction. So that's why instead of just saying R, I'm saying magnitude of R is equals to, or magnitude of R minus friction is equals to MA. So if you have the magnitude of resultant force, you can directly use resultant force magnitude is equals to MA instead of forward minus backward is equals to MA. And if you have a resultant of all the forces acting on a point, then you can use that as forward force. And if friction is backward force, so then you can use magnitude of resultant force minus friction is equals to MA. Apart from this, you need to know these trigonometric identities. You need to know that cos 180 minus theta is equals to minus cos theta. You need to know sine. Okay. Sine 180 minus theta equals sine theta. Then you need to know that sine theta plus 90 equals cos theta. Then cos theta plus 90 equals minus sine theta. And then sine theta minus 90 equals minus cos theta. And sine theta minus 90 equals sine theta. Let me quickly confirm that I haven't messed up any signs. Sine 180 minus theta equals sine theta. Cos 180 minus theta equals minus cos theta. Sine theta plus 90 equals cos theta. Cos theta plus 90 is equals to minus sine theta. Okay. And sine theta minus 90 is minus cos theta, and that's supposed to be cos theta minus 90 equals sine theta. This is cos. Okay, yes, you need to know all of these. Now we're ready to start the questions. Question number 1 of the worksheet. I'll send you the worksheet after the class. Two forces of magnitude 10 Newton act at a point O. Okay, so here's a 10 Newton force acting on a point O, and here's the other 10 Newton force acting at point O. Acting at a point O in the direction of OA and OB as shown in the diagram. The angle between the forces is theta. The resultant of these two forces has a magnitude of 12 newtons. Okay, so we know the magnitude of R. It's 12 newtons, just the magnitude. Okay, so using that, we have to find theta and find the component of the resultant force in direction of OA. Okay, let's find theta first. Okay, so resultant force is going to be somewhere over here. That's R. And R is 12. So I'm writing 12 here. 12 newtons. Okay. Now this R is going to have an X component and a Y component. Remember, X component is equals to forward force in X direction minus backward force in X direction. So since resultant is in this direction, forward of in the X direction is this, and backward in the X direction is this. So the forward is 10 Newton, the forward force is 10 Newton, and there's no backward force in this direction. In fact, there is a backward force in this direction. It's going to be the component of the other 10 Newton. So let me draw that component. इसको मैंने हटा दिया है. I'm going to resolve this 10 Newton into its components. Okay. So there's going to be a component in this direction, and there's going to be a component in this direction. Okay. For that, we need this angle, which is going to be 180 minus theta. That's 180 minus theta. So the opposite component is going to be sine 180 minus theta and 10 here. But we know from the identity that sine 180 minus theta is the same as sine theta. So that is just 10 sine theta. And this one is the adjacent component, that is the cos component. So that's going to be 10 cos 180 minus theta, which is cos 180 minus theta equals minus cos theta. So this component is going to be negative 10 cos theta. This is horizontal, so it does not have a vertical component. It does not need to be resolved. So now for Rx, we're going to use forward force in X direction minus backward force in X direction. So since resultant is this in this direction, so Rx is going to be here. So then forward force is the simple 10 Newton force. This is the forward force in X direction. So that's 10 minus backward force in the X direction, which is going to be this. So my bracket minus 10 cos theta. So Rx is coming out to be 10 plus 10 cos theta. Now for Ry, same formula. Forward force in Y direction minus backward force in Y direction. So the forward force in Y direction is going to be this direction where Ry is. So that's the upward force, which is 10 sine theta. There's no force in the downward direction, so minus 0. So that's Ry. Okay. Now we're going to use the formula R equals square root of Rx square plus Ry square. We already know the magnitude of R, that's 12, equals square root of 10 plus 10 cos theta square plus bracket 10 plus sine theta squared. It's going to be 144. If you square both sides, get rid of the square root on the right hand side. Square this, we have 100 plus 2ab, so 200 cos theta plus b square 100 cos square theta. And then the next expression becomes plus 100 sine square theta. Now, if you simplify this pink part, it becomes 100 common bracket sine square theta plus cos square theta. 100 bracket cos square theta plus sine square theta. And we know that this is equals to 1 from AS trigonometric identity, from pure 1 trigonometric identity. So that is just 100 now. So 144 is equals to 100 plus 200 cos theta plus another 100. So 144 equals 200 plus 200 cos theta. So we have negative 54 upon 200 equals cos theta. And then you take cos inverse of this. Sorry, it's 56, not 54. So that gives you 106.2. Cos inverse of this gives theta equals 106.2. If you have any questions, please ask now. We've just done part 1 so far. Okay, let's do part 2. Find the component of the resultant force in OA direction. So that's Rx, the horizontal component. So for part 2, you have to find Rx, and we already have the expression for that. 10 plus 10 cos theta, and we also know theta now. So 10 plus 10 cos 106.2. Which gives 7.2 newtons. Let me check. 10 plus 10 times cos 106.2 is 7.21. Yes, so there should be a 1 here in 3 significant figures. So let's quickly recap what we've studied so far. If there are a few forces acting at a point, then you can remove all these forces and say that there's one force R, the resultant force acting on this point. Now that R resultant force is going to have an X component and a Y component. This X and Y component is used in the Pythagoras theorem like this, connecting the R with Rx and Ry. And it will be used to find theta as well, using tan inverse Ry over Rx. So it helps you to get the angle of the resultant force. and Rx is found through here and Ry is found through here. You need the components in X direction and Y direction. And then Rx is the forward component in X direction minus the backward component in X direction. And Ry is forward component in the Y direction minus backward component in the Y direction. Okay. Question 2. Three coplanar forces of magnitude 10, 10, 6 act on a point P, act at a point P in the direction shown in the diagram. Okay. PQ is the bisector of the angle between the two forces of magnitude 10 Newton. PQ is the angle bisector, meaning this is going to be 30 and this is going to be 30. Find the component of the resultant of the three forces. So now you can remove the three forces and say that there's a resultant force acting on the object, let's say in this direction, R. So you have to find the component of the resultant force of the three direction in the direction of PQ. So PQ is here. So that means the Y component. That's the Y component of R. And in the direction perpendicular to PQ, that is the X component. So they're asking for the Y component of R and the X component for R of R in the next part. So this is Ry and this is Rx. So in part 1A, they're asking for Ry. Okay. And what is Ry? For Ry, you have to find forward force in Y direction minus backward force in Y direction. So that means we'll have to resolve these forces into its component. Okay. So let's look at this 10 Newton force. So there's going to be a horizontal component, which I can draw here if I'm using the 30-degree angle. It's up to you which angle you want to take. If I'm using the 30-degree angle, then that's my horizontal force and that's my vertical force. Okay. What you can do instead is take this angle instead. This is 10 Newton and you can take this angle, which is 60. So now this will be your vertical force and this will be your horizontal force. Final answer will be the same whether you use 30 as your angle and you use the blue triangle, or whether you use 60-degree as your angle and you use the green triangle. The final answer is going to be the same. You just need a right angle triangle around the force, whether it's this triangle or this triangle, it does not matter. Okay, so I'm going to stick to the blue one. So with blue one, the horizontal force is the opposite force, that is the sine force. So this is going to be 10 sine 30. But instead, I'm going to plot it here. It doesn't matter where I'm plotting it as long as it's parallel. Okay, so this is 10 sine 30. And this one is 10 cos 30. Okay. Now let's look at the other 10 Newton force, this one. So again, I'm going to use this triangle, the upper one. So then this component is going to be the sine component, the opposite component. So that's 10 sine 30, and that also I'm drawing here at P. So that's 10 sine 30 again. And the up component is 10 cos 30. So another 10 cos 30 upwards. Okay. Now let's take a look at the 6 Newton force. Now, if that's 30, this is going to be a right angle, and that's going to be 60, and then that's going to be 30, because this also forms a right angle. So this is a 30-degree angle. So there's 6 Newton force acting in this direction. So we form a triangle like this. That is 30. This is going to act rightwards. This is going to act downwards. Opposite to 30 is going to be 6 sine 30. Adjacent to 30 is going to be 6 cos 30. So I'm going to draw these two components now. So in this direction, there is 6 cos 30. And in downward direction, I'm going to draw the downward component here so that all the components originate from the same point. So this is the opposite component, so 6 sine 30. Okay, now we've resolved all the components. And now we can use find Ry. So Ry is going to be forward force in the y direction. So up forces. So that's going to be 10 cos 30. Another 10 cos 30 and minus 6 sine 30. This should be your answer for Ry. Number 2. This comes out to be 14.3 newtons. For part B, you're actually being asked to find Rx because that's the component perpendicular to the component in part A1. Okay, so perpendicular to Ry is Rx. Okay, for this again, forward forces in the x direction minus backward forces in the x direction. So forward forces are 2, which are 10 sine 30 plus 6 cos 30, and backward force is 1, which is 10 cos 30, so minus 10 cos 30. Which gives, sorry, the backward force is minus 10 sine 30. Okay, so we're left with 6 cos 30. So this is equals to 5.2 newtons. Or 3 under root 3. Or 5.2 newtons. Last part is find the magnitude and the resultant of, find the magnitude of the resultant of 3 forces. So for part 2, we have to find R, and we already have Rx and Ry, so that makes our job very easy now. you have to apply Pythagoras theorem. So Rx is, I'm going to use 3 under root 3 because that's the exact answer. Squared plus 14.3. If you have the rounded off, unrounded off answer, that would be great. You square that, take under root of that, and you get 15.2 newtons. So now I'm going to give the next part as homework.